the polarity of a covalent bond, and the symmetry in the geometry of a molecule are used to determine if it's polar. So for example, carbon and hydrogen have a similar electronegativity, so the electrons are assumed to be shared equally in this covalent bond. And therefore this methane molecule is nonpolar. Now when there's a prominent difference in electronegativity, such as with carbon and fluorine, then the electrons spend more time around the fluorine, so you get a partial negative charge, and that leaves behind a region of partial positive charge around the carbon. So we draw the dipole moments from the positively charged region to the negatively charged region. So here we can see the dipole moments cancel each other out, and due to symmetry this molecule is nonpolar. And you can observe that the dipole moments cancel each other out in 3D, where the geometry of the molecule is tetrahedral. Now generally where you have lone pairs of electrons, such as with the H2O molecule, the molecule is generally polar. You can see that oxygen is more electronegative than hydrogen, so you get the following regions of negative and positive charge. And if we draw in the dipole moments, so you can see here that the net dipole moment is going to point upwards because the molecule is not symmetric, and therefore this molecule is polar. And I'll leave it for you to determine the polarity of these other molecules and post your answers or questions in the comments.